Welcome again. We're still radioactivity. Today we're looking at nuclear reactions. Nuclear reaction. So nuclear reaction is divided into two, which are what? Nuclear fission, nuclear fission, and nuclear what? Fusion. So you have to know the difference between these two, nuclear fission and nuclear what? Fusion. In this nuclear fission, a heavy nuclear is being what? Divided into, and doing so it produces what? Smaller nuclei. But in fusion, to fuse, more than one, or let me say two nuclei coming together to fuse together and produce what? Giving what? A heavy what? Nucleus. So in nuclear fission is splitting up of what? Heavy atomic what? Nucleus by what? Neutron what? Bombardment. By neutron what? Bombardment. So in fusion now, no, in fission, sorry, fission, nuclear fission. In nuclear fission, where we say what? The splitting of what? Heavy atomic nuclei by neutron bombardment. Are you getting me? It results in a formation of what? Approximately what? Equal light what? Nuclear. Are you getting me? Equal light nuclear and more neutrons. You also produce gives out what? More what? Neutrons. One neutron can cause what? The formation, the unstableness of the nucleus. And after that large size of what? That heavy atomic nucleus split, it now produce smaller what? Nuclear and more than one neutron. More than one what? Neutron. Remember, only one causes what? The bombardment. For example, in uranium has atomic mass of what? 235 and number of protons is 92. If we decide to form that radioactivity could be what? Natural and it could be what? Artificial. So let's assume it's an artificial one, man causing it, introducing what? A neutron. This neutron being introduced will cause this man to be what? Unstable. And when this man is unstable, the nucleus will break up, giving us what? 144 what? 56 watts plus chromatin plus 36. What do you observe here? One neutron causes the unstableness and is giving out what? 2 after forming this what? Nuclear. And please take note because we'll be moving on binding energy very soon. This might have atomic mass of 235 and these two have atomic mass of what? 234. This neutron taking 1. Are you getting me? So this is 234, this is 235. In binding energy, we are looking at the difference in mass. The original element before the disintegration and the product, the difference between them is what we use to calculate the what? Binding energy. Take note of that. This is fusion, a heavy nuclei bombarded with what? A neutron, and produces two elements and some what? Uh, neutrons, and giving out what? Large amount of what? Energy. The when it's being controlled in nuclear plants, and a nuclear bomb, this energy is allowed to destroy. It's allowed to destroy, and any uranium not used up will be triggered by this, which should now form what? Chain reaction. Okay. From there, we now move to what? Nuclear fusion. In fusion, let's assume deuterium, which is an isotope of what? Hydrogen. These two are what? Isotope of hydrogen meeting together, giving us what? Helium. Helium has atomic mass of 4, and 2 protons, which makes atomic number to be what? 2. This is 2 plus 3, 5. That means 1 here. 1 plus 1 is 2. 0 will be here. You know what this is, right? And also what? Energy. This is nuclear fusion. 2 small nuclei coming together, and this happens what? Take note, at extremely high temperature and pressure. This nucleus come together under what? Heavy what? High temperature and what? Pressure. Deuterium and what? Tritium. No, this is tritium and this is deuterium. Deuterium and tritium coming together under what? Extremely high temperature and pressure to form what? Heavy nucleus. Heavier nucleus. This is heavier than this, than each of them. Heavier nucleus which release of what? Huge amount of energy. So these they fuse together to produce helium. They fuse together to produce what? Helium. Are you getting me? So nuclear reaction, which could be fission or what? Fusion. It could be fission or fusion, occur with a loss in mass. Total mass here is 5. The mass of this man is what? 4. 2 plus 3, 5. But here we have 4. The neutron has reduced. So there's a loss in what? Mass between this element and these two elements. These major element here, these are 2 elements. This is 235. 144 plus 90 will not give 235. There's a loss in what? Mass. This is 2, yeah, plus 3, giving us 5. But here has what? 4. Taking away these guys. Are you getting me? So you see the loss in mass, and whenever nuclear fission and nuclear fusion occurs, taking note there's a loss in mass, and nuclear fusion happens at an extremely high what? Temperature and what? Pressure. Always take note of that. So the mass defect now is what? The mass of the original substance minus the mass of the what? Product. Where say mass of original substance minus mass of product, to give you what? The what? Mass defect. And this will take us to what? Our next topic. Our next subtopic which we'll be discussing, which is going to be what? Binding energy. Wait for the video. If you haven't subscribed to this channel, you are really missing a lot. Do well to subscribe. Call your friends, call your classmates, inform them, tell them about the channel Physics Simplified at Youth Tutor, and you'll be doing them good. Thank you.